All right, so like I said, you need your Chromebooks out today, because we will be doing some calculations on the Chromebook. Not right necessarily from the start, but we are going to be in your note packet today. We're going to kind of be jumping around a little bit with it, so we'll have to fill some stuff in and all that good stuff. I do want to remind you that tomorrow you will have a quiz, a formative quiz in class. So you'll have that to do tomorrow in class, and then you can be working on homeworks once you get done with that, all that fun stuff. Okay? So we are in your note packet. We're going to start on page 6, but we're going to jump around between page 6 and page 10 here pretty relatively quickly. So what I would like you to do is on page 6, it gives you a set of data, okay, single variable data. I want you to find me the measures of central tendency, the mean and the median. Okay, I want you to find me the range of the data set, and I want you to make me a box plot for that data. Okay, so mean, median, range, and a box plot for it. Okay? Then down at the bottom, I do want you to do number 4 also, where I want you to come up with the explicit equation for that particular sequence. Okay? So I'll give you a few minutes to come up with that. If you use Desmos for measures of central tendency, that's fine. Just know that tomorrow you will not be using Desmos on your quiz. Okay? So however you want to do it is however you want to do it. Okay? Go for it. So my measures of central tendency, I can't just give numbers there because I'm asked to give 2 of them, and they're both just numbers. So I would have to say that the mean here is the average, add them all up and divide by however many there are, is 40.941. And the median, the middle of them, after I order them all in order, the median is 44. So I'd have to put them in order first. If I'm doing it by hand, wink, wink, nudge, nudge, tomorrow on your quiz. Doing it by hand, no Desmos tomorrow. Okay. Find the low end, find the high end, and that gives me the range. Maximum minus minimum, which in this case was 50 minus 30. So my range is 20. Okay. Then find the median, the middle one. Then find the median of the lower half of the data. Find the median of the upper half of the data. That gets me my Q1 and my Q3, to which then I can make myself a box plot. And so then that box plot would look like this. Bonus question, what is the skew on this data? Left skewed, because the left side of the box is bigger, and median is closer to the right side of the box. So this is a left skew set of data. Okay? Questions on it?
Not gonna like do this for like our phone.
No, you're gonna do it for your quiz tomorrow. You're just gonna have to do it by hand, like we did on Tuesday. Mm-hmm. Mm-hmm. Yep. Yep. We already taught you how to do it by hand.
Oh my
Yep. And then lastly, we have number 4 here, where that one is creating an explicit equation for the sequence. I'm going to go with f of x as the name of my function, x being my variable. Okay. My first term is 20. I'm multiplying by 2, so that means that I'm going to be multiplying in my explicit equation, and I'm going to be multiplying by 2 raised to the x minus 1 power. Okay. If this were an arithmetic sequence, I would have still started with 20, okay? But then I would have added whatever it is that my common difference is to get the next term, and then multiplied that by the quantity x minus 1. Okay? Good? All right. So what we're going to be doing today then is we're going to kick it up a notch. So when we were talking about this set of data, we were talking about something called a univariate, one variable data, okay? High temperatures, low temperatures, whatever you want to talk about, test scores, whichever one you prefer, okay? All right? So we were talking a little bit about that. Today now, what we're going to be doing is we're going to be talking about bivariate data. So there's going to be two things. So we're going to be comparing two different things. Like, for instance, comparing the number of hours that you spent studying versus the test score that you got or will get tomorrow. Okay? That would be a bivariate where we're comparing two different things. Okay? And then what we're going to be doing with that is we're going to be creating what's called a scatter plot. And a scatter plot is just that. It's a bunch of plotted points that are all scattered about. Okay? So we'll create a scatter plot for it, and then we're going to determine this thing here called the correlation coefficient. The correlation coefficient is how tight your data is to a line. Okay? We want to know if there's a linear relationship between your data. And so that's what the correlation coefficient tells us. Okay? So on page 10 in your note packet, there's a chart on page 10. Okay? What I want you to do is I want you to fill in these blue words in that second column before I show you what they look like. Okay? So if the correlation coefficient is 0, there is no linear relationship between the variables. Mason, wake up. Start writing. That'll keep you awake. Okay? There's no linear relationship if the correlation coefficient is 0. If the correlation coefficient is between 0 and 0.7, we call that a weak positive relationship. If the correlation coefficient is between 0.7 and 1, we call that a strong positive relationship. If the correlation coefficient is between 0 and negative 0.7, we call that a weak negative relationship. And lastly, if it's between negative 0.7 and negative 1, we call that a strong negative relationship. Okay. So the pictures of those that you can add in now look like this. Okay? So please add in the corresponding pictures to go along with them. They are not in the same order, so find the correlation, strong positive, weak positive, none, weak negative, strong negative, and add in those graphs at this time, please. Anybody see a trend in the data, positive to negative? See something that we can relate it to, maybe? Got it? Or just stretch it? What do you got, Preston? So it's kind of like positive and negative slopes, right? Yeah. So a negative correlation would be going down and to the right. A positive correlation would be going up and to the right. Yeah, exactly. That's a great observation. Okay. So that those correlations are just like slopes. Okay. Okay. Anybody need more time to copy down those graphs? Okay. All right, so this is going to come now to the Desmos time of the day. So here is a bivariate. So we have two variables. We're comparing two things. This, I believe, is back on page 6. Maybe it's on page 7. We're on page 7. Okay. So we could say here, again, I'm just making this up as I'm going along. I should have made it up last night, but I didn't. Where X here is the number of hours studying. Okay. And then we could say Y is the score on a test, we'll say out of 13. Okay. All right. So that we're comparing. Now, should be a positive correlation, right? The more you study, the better score you get. That would be a positive correlation. Okay? The more you study, the better score you get on the test. Okay? So here's how we go about adding. So if you haven't already added that Y row into your chart, please add that Y row into your chart. Okay. Oops, this one's done. That one's done too. There we go. Now we're there. Okay. So how we go about adding this into our figuring out the correlation coefficient of it. So we're going to go into Desmos and we're going to make ourselves a table. Okay. So in the X column of our table, we're going to put our X value. So the number of hours that we study. We're going to fill in that chart. Okay? So that was 2, 2.3, 3.3, 3.7, 4.2, 4.6, 4.5, 5, 5.5, 5.7, 6.1, and 6.4. Okay. Now, we got to go over to the Y column, and this is where it's important. The Y's have to match up with the X's that they're underneath. You can't just randomly put the Y's in wherever you want them to be, because that would be a different relationship. So next to the 2 for the X value has to go a 4, because that's what that one was. 2.3 has to be 6.3. 3.3 has to be 6. 3.7 has to be 7.2. 4.2 has to be 7.6.
4.6 has to be 8.2. This one has to be 9. 9.4. 8. 5.8. 12.2 and 10.5. Okay.
Now I don't see mine yet because I was way over on for the box plot. But if I hit this magnifying glass right here, that's going to zoom in, and there is my scatter plot. Okay. It created a scatter plot for me, which, based off of what we just learned, come on, zoom in there, too far. Oops, I think I zoomed in a little too far. Based off of what we just learned, does that still have a strong positive or a positive correlation, I should say? Yeah? Okay. Looks pretty strong, right? Okay, because you can definitely see it's trending in the upward pattern as we're going to the right. Okay? So how we actually figure out that correlation is we can do it one of two ways. The first way is you can go into the keyboard here and you can go into functions and scroll on down to CORR, C-O-R-R, or you could just type in C-O-R-R. And then you want to have a correlation and you want to compare X1 to Y1. So you're going to do X1, comma, Y1. And that gives me a correlation coefficient there of 0.7548, okay, which is pretty good. Okay. The other way that you can do it is you can do a linear regression on here. And so because I've got variables in y sub 1, I'm going to use y sub 1. And then I'm going to use, I think it's called the tilde. Isn't it that single wavy type one? Isn't that called a tilde? Okay. I think that's what it's called. And I want to put in a line of regression, so that's going to be mx, but I'm going to use mx sub 1 plus b. And then there is my linear line of best fit. And then what I'm looking for there, it's open. And then what I'm looking for there is this R value down here at the bottom. Okay? That R value matches my correlation coefficient that I just calculated. Okay? So that's one of the two ways that you can do that. On the next page in your note packet, I have changed around the data points, the Y data points. I kept the X ones the same. So all you have to change on your table is go in and overwrite your Y values first. Okay? So if you do that, I'll give you a moment here to write these down. And then find me the correlation coefficient for this new data set. I got a correlation coefficient. Oops, I guess I didn't get a correlation. There you go. I got a correlation coefficient of 0.315. Really 316. Yes. Okay. One more. Find me the correlation coefficient for this set of data here, which is number 4 in your notes. So you got to write down the Y's again, just so you have it in there. Anybody? What did we come up with a correlation coefficient? Close. Negative, right? Because it makes a difference, right? Because this had the data going down into the data was trending down into the right, so we got to have that negative sign in there. Okay? Yep. All right. Not a very strong one, but okay. All right. So get out your green homework packets now. I want to explain one might be new concept for you. Okay. So on your homework, it starts out with a dot plot. Okay? Just like how a box plot has a box in it, a dot plot has dots on it. Okay? Okay? So a dot plot puts a dot at every number in your data set, if you will. Okay? So what this is saying here is that in your data set, there's 1, 1. Okay? There's 3 2s. There's 3 3s. There's 6 4s. There's 4 5s. There's 2 6s. And there's an 8. Okay? Okay? So if you had to write out your data for that, that's how you would write it out. It's a little bit goofy when you're trying to find, so like when it says find the median, that's the middle number, you actually work left to right, but bottom to top. Okay? So you go, it's kind of like you go this way. So you go here, and then you come back down here, and then you go up this way. And then you come back down here, and you go up that way. And then you come back down here, and you go up that way. And then you come back down here, and you go up that way. So you work left to right, but bottom to top. Okay? So if there was a, so how many data points do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We've got 20 data points, right? So that's an even number. So I've got to take the average of the 10th and the 11th data points is my median. Okay? Count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my 10th data point, which makes this my 11th data point. So my median is right there. Okay? That's how you read a box, or excuse me, a dot plot. Okay? You only have to answer these 2 questions for the dot plot. Then it's going to change up back to a list of data. Okay? And with that list of data, it's asking you to create a dot plot for it. Okay? Then it's, excuse me, find the mean and median. Then also make a box plot for that data, and then answer a couple of questions after that. Okay? Then on the next page, on page 8 now in your homework, there are 6 graphs there, and underneath those 6 graphs, focus here, ladies and gentlemen, focus here, because then I don't have to answer these questions 17 times, and you know what you're doing, okay? I am literally explaining the homework to you, and you're trying to do the homework while I'm explaining it to you, okay? Not the smartest choice, okay? On this page, there are 6 graphs. Below there are 6 correlation coefficients. Okay? You need to match the correlation coefficient at the bottom to the graph. There are no repeats. You got to use all 6 of those for all 6 graphs. Okay? Again, no repeats. Then on page 9, here's where you're going to use Desmos. You're going to use Desmos for those two problems. For numbers 8 and 9, you're going to use Desmos to figure out what the correlation coefficient is of that data. Then 10 and 11, you're going to answer questions about correlation coefficients. And then on page 10, it gives you, I believe is it 6 or is it 8? No, it's 6. Okay? 6 different sequences that it would like you to find the explicit value of and a specific term using your explicit form. Okay? Any questions on the homework? You have the remaining 20 minutes to be working on the homework.